Okay, so in this question, we're actually doing a bit of a surface area calculation because we're being asked to make several cans like the one drawn below. And we're being told, this is kind of a theoretical case, but we can cut from a sheet of metal that has an area of 2,750 square inches. Okay. How many cans are we able to make assuming 100% efficiency? So there are a couple of things to recognize. 100% efficiency is very much theory. It's not really what's going to happen. Okay. Another thing is it's not telling us kind of the way that the metal is already cut. Maybe some pieces are already cut to the sizes we need, or there's a lot of what ifs, but we're basically going to assume that there's no waste, okay? Which makes it a little easier to go ahead and kind of figure out some of what we're able to do. It saves us the actual part of figuring out how do we fit 100 circles or 10 circles or however many we're dealing with within that space. Okay. What we do need to recognize is the calculations that are still going to be needed to work here. Okay. So the first thing is probably recognize that we're actually working with two circles, okay, a top and a bottom, and then there's whatever we have when we unwrap the sides of that cylinder. Okay. So however we look at it, okay, we know that there's going to be kind of the wrapped portion that goes into that. Okay. Now the length, okay, at least of the side that I drew it, okay, is going to be equal to the circumference of one of these circles. So that should kind of be telling you, we need the circumference formula. Okay. So circumference of a circle, you guys may remember, is equal to 2 times pi times r. Okay. The rest of this, okay, would basically be circumference times the height. In this case, we're given the height of 4.5 inches. Okay. And if you're looking at a formula sheet, you may actually, just go straight to the surface area of a cylinder and recognize that surface area of a cylinder is going to be equal to 2 pi r times height plus 2 times pi r squared. That actually saves us, kind of working through the circumference to go ahead and figure out circumference plus a bunch of other stuff, because area of a circle, is actually kind of wrapped in here as the pi r squared. Okay. So area, pi r squared, circumference, the surface area formula kind of makes it a little easier for us to kind of pick through this. Now, it's again knowing the different concepts, how you can apply some things you may remember from memory. Circumference of a circle, you probably remember that by memory, or take enough math and you will be remembering that by math. Area of a circle, the pi r squared part, again, is something that you may remember from math, but this is saving us, kind of the general set of data. Okay. So then we have to look at the data itself. Okay. We know our height, okay, but what we can easily mix up, okay, is the value of 3. Okay. 3 in this case is actually our diameter of 3. Okay. They're actually showing it measured from side to side, presumably going through a center point. Okay. What we need to recognize is the radius of that, okay, is going to be 1/2 of that value. So radius is going to be 1.5 inches. From there, we're basically going to go ahead and start calculating the area of one can. Okay, so one can has a surface area of the 2 times pi times radius 1.5 times height of 4.5 plus 2 times pi 1.5 inches squared. Okay. Now the other thing, and this is something to pay attention to when you're working on like a test or an exam or something where there's going to be fixed values. In this case, we're not going to use pi as the symbol in our calculator. Okay, we're not actually going to call on that that value. What we will be doing though is basically swapping in that 3.5. Okay, so 2 times 3.14 okay, for pi times 1.5 times 4.5 plus 2 times 3.14 times 1.5 squared. Now at this point, it's worth going ahead, firing up the calculator, and running the calculations. Okay. So 2 times 3.14 times 1.5 times 4.5 plus, again, order of operations, we'll basically have these grouped separately. 2 times 3.14 times 1.5 squared. In this case, the surface area of one can is going to be equal to 56.52. We then have to calculate how many of those cans can we actually get from that 2,750 square inches. Okay. So, assuming our 100% efficiency, we're basically asking ourselves 2,750 inches squared divided by 56.52 inches squared. Okay. Okay. And here we're basically seeing that that's going to be equal to 48.655 cans. Now, the other part of this that it's easy to go ahead and kind of get lost in some of the details is that we're looking for the number of cans. How many cans can we make even if we're assuming 100% efficiency? Because we can't consider 0.655 cans a complete can, we actually have to round down. So even though we may want to round up, okay, the correct answer here is going to be 48 cans because we have to round down to the nearest whole can. Basically, chop off the decimals and we're left with our answer. So hope this makes sense. You know, knowing your formulas can lead you to finding other ways of kind of solving this. But if you've got a formula sheet, if you can look at the references available, you know, a surface area calculation for a cylinder could be a little bit faster than you kind of working your way through it. But both approaches are fine. You'd actually find the numbers are pretty much going to be the same either way. Maybe a little bit of a rounding difference because you have to deal with the circumference separately from the combined. But either way, you're actually losing, you know, some of that potential error by having to round down. So another way of kind of looking at a engineering problem with mathematical calculations, you know, kind of a common practice. So I hope this helps you out with understanding surface areas and at least recognizing that you might have percentiles to deal with. But good question to kind of get started with. So Hope this helps. If you have your questions, make sure you're leaving them in comments and letting me know so I can continue to help you out.